All right, my friends, you have made it. You have made it to the end of this stoichiometry train. Woo woo! We have come to the caboose. The stoichiometry conclusion. The mass to mass stoichiometry problems. Yes, this is the big kahuna, people. This is as big as we go in stoichiometry. Mass to mass. Let's do this thing. Alright, there's only one question. Only two examples. Hopefully it's a lot shorter than the last notes, right? Alright, let's get started. So, asking, how do I solve mass to mass problems? So, to begin with, mass to mass means you have grams of one substance that you're given, and you have to find the grams of a different substance in the reaction. Didn't believe it was possible? It is, my friend. It's totally possible, and you're totally going to do it. All right, let's get started with an example. Determine the mass of H2O produced from the decomposition of 25 grams of ammonium nitrate. Dun, dun, dun. Are you smart enough to figure out the chemical reaction? If you think you are, you should pause and try to figure it out. Did you get it? If not, there it is. Okay. Decomposition of ammonium nitrate into dinitrogen oxide and 2 moles of water. Beautiful. Okay. Let's take a look and see how the heck do we solve this, Miss Creo? How the heck do we solve this? All right, let's take a look. All right, here are the steps to solving. First, always verify the reaction is balanced. Number 2, because this is a mass to mass, that means it's a big one. We are going to set up 3 bridges. The first one goes from grams to moles of our given. The second one to moles of the unknown. And then to grams of the unknown. Okay, so we're going to have 3 bridges, 4 slots. Very left goes the grams of what we're given. Then we got to go to moles of what we're given. Then the next one over is the moles of our unknown, what we need to solve for. And then the very last one is our grams of our unknown. Okay, so let's see how this works. Okay, so here it is. Once again, determine the mass of water produced from the decomposition of 25 grams of ammonium nitrate. So let's take a look at the question, and remember, dissect the question. What are we given? What do we need to find? Everything else is just blah, blah, blah. Okay? So, what are we given? So, determine the mass of water produced from the decomposition. Oh, okay, here we go. 25 grams of NH4NO3. That is what we're given. Okay? Okay, so then what do we need to actually solve for? Well, it says determine the mass of water produced. Okay? There's the key words here. And mass, remember, is grams. So here we see that we are given grams and we need to get to grams. So this is the big kahuna mass to mass stoichiometry. So that means that, like we put in our steps to solve, it is a 3-bridge problem. Yes, the fun has begun. 1, 2, 3. Bam. Okay, so we got 3 bridges. We've got 4 different slots that we're going to put things in. Okay, so don't let the vast bigness confuse you. Let's always start with what we're given, right? Goes in the very left-hand corner, what we're given. And in the question, we're given grams of NH4NO3. Okay, so that goes there. If that goes there on top, it's going to go down on the bottom right. So let's just do it. Put it there. Okay. Now, we're going to try a slightly different approach as we fill this in. Okay, we know what we're given. We know what we need to find. All right, we need to find the grams of H2O. So we know that needs to be our destination. So we're automatically going to put grams of H2O over here. Okay. All right. So now what we need to do. Okay, so we can't go from grams of one thing to grams of something else directly. We always must go to what? That's right, moles. So our first bridge is going to take us from grams of NH4NO3 to moles of NH4NO3. Okay, it's got to be the same substance there. We can't go from grams of NH4NO3 to moles of H2O. That makes no sense. You can't compare the two. It's like apples to oranges, okay? Unicorns to bears. You can't really compare them. So you always have to go to moles of your given substance first. Okay, so in this one we need to find, basically we're going to have our molar mass for the given. Okay, that's our first bridge. Now, the second bridge, okay, is always going to be a mole ratio. Okay, because we eventually need to be talking about water rather than ammonium nitrate. So the next is going to be a mole to mole ratio. So moles of NH4 NO3. I'm going to squeeze that in there. Okay, because we know that on the bottom here we have to have, I'm sorry, I totally messed up. It shouldn't be NH4NO3. It should be moles of water. Silly, silly teacher. Okay, because on the bottom we have moles of NH4NO3. Woo! Yikes, I probably just confused some, but that's alright. Okay, so mole ratio between water and ammonium nitrate. And then our last one, okay, we have to cancel these moles of H2O. So there we get, again, we're going to have our molar mass of our unknown, like what we need to find, right? That's what unknown means, is what we need to find. So we've got our molar mass for water. All right, so once we have our units, then we can plug in our numbers. So the number we always start with on the left is what we're given in the question, 25.0 grams. Please, if it says 0.0, put 0.0, because that's important when it comes to significant figures. Okay, don't just drop off the 0, because it's very precise. It's exactly 25.0 grams. It's not 24.9, it's not 25.1, it's exactly 25.0. Okay, now our first one we said is our molar mass. So we're going to take a look at our periodic table and add up N plus 4 H's plus another N plus 3 oxygens. So pause a second and do that. All right, I got 80. Hopefully you got 80 as well. And now when we look on our periodic table, remember it's 80 grams, because it's molar mass, so 80 grams in 1 mole. So the 1 goes on top with the mole, the 80 goes on the bottom with the grams. Okay? All right, moving on. Next slot over. We have a mole to mole ratio. Okay, where do we find mole ratios? That's right. In our equation, we have to look at the coefficients. So coefficient for water is 2, so the 2 goes here for moles. And the coefficient for NH4NO3 is 1, so 1 goes on the bottom. Everybody still with me? I hope so. If not, pause, go back, and take it one step at a time. Okay, figure it out till it clicks. Our last is the molar mass of our unknown, or what we need to find. So it's the molar mass of water, because that's what we need to find in our question. So again, molar mass means we go to our periodic table. We're going to add up an oxygen, which is 16, and 2 hydrogens, which make 18. And because 18 is the grams in 1 mole, the grams go on top, so 18 goes on top, and 1 mole goes on the bottom. Okay? So that's where all of those numbers come from and how we get it. Now the last thing we have to do is just the math. We multiply everything on top together, and we'll divide it by everything on the bottom when it's multiplied together. So it's like a big, huge kind of fraction in a sense. Okay? So take a minute, pause, grab your calculator, and do the math, and then restart the video. Okay, so you should have gotten 11.3 grams of H2O. Okay, that should be your final answer, 11.3 grams of H2O. So if we start out with 25 grams of ammonium nitrate and we let it decompose over time, it will form 11.3 grams of H2O. And the remainder of that 25 will be that dinitrogen oxide gas. Okay. All right, you with me? Did you get it? That's why we're doing one more example. All right, let's take a look. All right, here is the final example that we'll do in these notes, and then tomorrow we'll have lots of more fun with stoichiometry and our mass-to-mass stuff. Okay, so how many grams of glucose can a plant make if it uses 150 grams of water? Dun, dun, dun. Okay, so do you remember back to biology? Or did you stick around long enough to do the extra credit little problem there at the last notes? Yep, there was extra credit. Huh? Yep, there was extra credit last time. All right, what we need to do is figure out this chemical reaction. So if you think about it, plants use carbon dioxide and water, and they make what? Glucose and oxygen. So let's write that down. Okay, there it is. So we've got our question, we've got our equation. First things first, make sure the equation is balanced. Is it balanced? Oh no, it's not. It's not balanced, you silly kid. Okay, stop and balance it. All right, that's what you should have gotten. Now, how many of you actually stopped and balanced it on yourself? Pretty sure the odds are very low, but that's all right. Let's move on. Okay, so we're going to dissect again. We're going to look carefully at the question to figure out what we're given and what we need to find. All right, so how many grams of glucose? Okay, that's what we need to find, right? Grams of glucose. This is what we need to find. Can a plant make if it uses 150 grams of water? There's what we're given. Remember the number and the unit there is always what we're given. Those are two very important things. And once we've identified that, we can figure out how many bridges to use and start setting up our bridges. So if we look, we have grams and grams. So guess what? This is a mass-to-mass stoichiometry. Okay, so how many bridges does it need for mass to mass? That's right, 3. 3 fun bridges. So let's draw our 3 fun bridges. Okay, there they are. Isn't it beautiful? It's almost like the Golden Gate Bridge. Oh, it's so serene. Anyways, let's move on. We got to start with where we're given in the question. So in the question, we're given 150 grams of water. So that's our first starting unit, grams of H2O. Okay, if we put grams of H2O there, then we got to put grams of H2O here to cancel it. That's easy. All right, and then we're going to set up what we need to find in the very right-hand side. So we need to find grams of glucose, C6H12O6. Yikes, I ran out of room. That's okay. Okay, so another thing kind of notice is that if we divide, oh here, let me do this first. Okay, so grams, we have to go from grams of water to moles of water first. Always gotta go to moles of what you're talking about before you can even start comparing. And then after moles of water, you can go to moles of your final, so C6H12O6, right? And so the moles of that will go down here, and the moles of water will go here. Okay, you guys with me? We just did those bottom ones to cancel the tops, right? Okay, here's kind of an easy, well, hopefully it's easy. It's another way you can look at it. If we divide this bridge in half, okay, we see that this side, okay, on the top deals with water. This side deals with what we need to find, C6H12O6. So if you put in what you're given and what you need, the things right next to it have to be the moles of those same substances. Okay, because water, the first part of it's going to be the substance you're given, and the second part of it's going to be the substance that you have to find. So keep that in mind if you're kind of confused, like, oh, shoot, where does the first bridge go? I don't know. Okay. If you're going grams to grams, it's going to go to the, the first bridge is going to go to moles of whatever you start with. And then, from there you got to go to moles of whatever you're ending with, because you got to get to grams of whatever you're ending with. So kind of, hopefully that makes sense. Okay, so let's start plugging and chugging. Now that we got these units, our first number is 150, so that goes here, 150 grams. And what we have here in our first bridge, moles of H2O and grams of H2O. Why, this is the molar mass, Mrs. Carrillo. You are absolutely right. Molar mass, which means, where do we look? Periodic table. Ah, see, this is just, it just goes. It just goes. Okay, so molar mass of H2O. Well, we got an oxygen, 16. We got 2 hydrogens, which is 2. 16 plus 2, 18. Now, is it 18 moles in a gram, or is it 18 grams in a mole? That's right. It's always grams in 1 mole. Okay, there you go. Molar mass. All right, next part of our bridge. What do we have? Moles of C6H12O6 and moles of H2O. Why, look, Miss Creo, that's the mole ratio. Why, you're so correct. Look at you. You're getting this stoichiometry thing. Okay, so where do we look for mole ratios? Chemical equation. Coefficients. That's right. Okay, so what's the coefficient for C6H12O6? Why, it's 1. Yep, so the 1 goes right there. What's the coefficient for water? 6. Yep, okay. 6 goes on the bottom with our moles of water. Okay? Breathe. You can do it. Everybody with me so far? Good. Okay, here's our last step, our last bridge. Crossing the last bridge from moles of C6H12O6 to grams of C6H12O6. Okay? So here we've got grams of glucose and moles of glucose. And what is that? That's the molar mass. You are so correct. Okay, this is the molar mass of our glucose. So what we need to do is look where? Periodic table, that's right. Okay, so take a minute, pause, and figure out this mumbo jumbo glucose grams thing. All right, hopefully you came up with 180 grams. That's right. Glucose is a big molecule. It's 180. Whoa, hello. It's 180 grams in, how many moles is that equal to? 1. That's right, 1 mole. Okay, so 180 grams Because the grams are on top, the 180 goes on top. Moles are on the bottom, so the 1 goes on the bottom. Okay, so again, what's left to do now? That's right, our math. So let's multiply everything on top. Let's multiply everything on the bottom, and then divide the two. Okay, so 150 times 180, and then divide that by whatever 18 times 6 is. Okay, so pause and do that. Okay, you should have gotten 250 grams of C6H12O6. All right, we did it. And we survived. Look at you. You're still here. That's awesome. So if we start out with 150 grams of water and we give it to a plant, it's going to make 250 grams of glucose. That's cool. I can live with that. All right. Okay, that's it. Peace out, brother. We'll see you tomorrow. Dun 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 dun. Extract.